Hello everyone, we are still in the introductory part of statistics. In this video, we are going to talk about measures of dispersion. While we have learned how to measure the closeness of a set of data to the center of the data, that is, measure of central tendency in the previous video, we can also measure how the values of a set of data spread away from the center of the data. This, in statistics, is called measure of dispersion. There are many types of measure of dispersion. They include the range, variance, standard deviation, interquartile and semi-interquartile range, mean deviation, percentiles, and the likes. In this video, we are going to discuss the range, variance, and standard deviation. First, we start with the range. The range is the easiest measure of dispersion. It is the positive difference between the highest value and the lowest value in a dataset. Let's take some examples. The first example says, the data below shows the time in hours spent at work by the workers of Colony Model School. Find the range, and we are given the data here. So these are the time in hours spent by different workers. Now, here is the solution to the question. The formula for range is range equals highest value minus lowest value. Now, let's come to this data set. What is the highest value here? In this column, it is clear that 8 is the highest value here. Also, in this column, we can see that 7 is the highest value. While in the third column, we can see that 9 is the highest value. In the fourth column, we can see that 7 is the highest value. And also, in the fifth column, we can see that 7 is the highest value. Therefore, we can see that 9 is the highest value in this whole data set. Now, we need to get the lowest value too. To get the lowest value, we check through each column again. In the first column, 3 is the lowest value. In the second, 3 is also the lowest value. In the third, we have 4 to be the lowest value. In the fourth, 6 is the lowest value. And in the fifth, 4 is the lowest value. Then we can see that in the whole data set, 3 is the lowest value we have there. That is, nothing is below 3. No values is below 3. Therefore, since our lowest value is 3, we apply this to the formula. The highest value is 9 and the lowest is 3. So the range equals to 9 minus 3 and the range equals to 6. Now, let's look at another example. we are to find the range of the heights of students in the data below. So we have the heights in the first row and the frequency in the second row. Here 6.5 has the frequency of 10. This means we have 10 students with a height of 6.5. Also, we have the height 6.7 having frequency of 3. This means we have 3 students with a height 6.7. So the data continues like this. Now, in finding the range, we don't consider the frequency. Rather, we consider our values, which in this case is the height. Since the height on this row, in this row is arranged in ascending order, definitely 6.5 will be the lowest value and 8.0 will be the highest value. Therefore, here is the solution. Using the formula range equals to highest value minus lowest value, we have range to be equal to 8.0, which is the highest value in this case, and 6.5, which is the lowest value in this case. Therefore, our answer is 1.5. How do we calculate the variance? First, what is the variance? The variance is the value obtained by dividing the summation of the squared of the mean deviation by the number of observations. To get the variance, we need to get the mean first. Use the mean to deduct the deviation of the values from the mean. Square the deducted deviation and sum it up. And lastly, we divide the result by the total number of observations. The formula for variance is given by variance is equal to summation into x minus x bar close bracket square divided by n, when we have a data that is not given in the frequency table. Or we can also use the formula variance is equal to summation f into x minus x bar close bracket square divided by n, where the f stand for frequency and the n stand for number of observation. The x is the value and the x bar is the mean. We will see how to apply this when we get to the examples. Now let's go to the standard deviation. This is the square root of the variance. That is, standard deviation equals to square root of variance. That means for you to get your standard deviation, first you have to calculate the variance, and once you have your variance, take the square root of it. That is your standard deviation. Let's take some examples on variance and standard deviation. The first example is to find the variance of 71, 73, 75, 77 and 79. Here is the solution. Just like we have highlighted above, the first thing to do is to find the mean. This will be done by using the formula x x bar equals to summation x over n, and this will give us the addition of all the values we have here. Addition of 71 plus 73 plus 75 plus 77 plus 79. That's our summation x. Divided by n. N is the number of values that we have. Sometimes it's also represented by summation f. In this case, we use n. Now, how many values do we have in this data set? We can easily get that by counting the number of values we are given. 1, 2, 3, 4, and 5. So that means we have 5 values in our data set. Therefore, our n is 5. And so, we have 375 divided by 5. And the answer to that is 75. Now, the next thing we do after getting the mean is to draw a table. Now, you can see that in this table, the values in the data set are arranged in one column. Then the next column that follows is we have d equals to x minus x bar. In other words, we call it deviation. This d stands for deviation. That is, how far is this value from the mean? Now, for the first value, what we need to do is subtract the mean from the first value. So we have 71 minus 75. This 75 is the 75 of the mean that we got. If our mean is, for example, 80, then what we will be subtracting here will be 80. But in this case, for this example, is 75. Therefore, we are subtracting this mean from each of these values that we are given. So we have 71 minus 75 equals to minus 4. 73 minus 75 is equals to minus 2. 75 minus 75 equals 0. 77 minus 75 equals 2. 79 minus 75 equals 4. Now, after getting this deviation, what we need to do is square the answer that we get. That is, minus 4 square will give us 16. Minus 2 square will give us 4. 0 square remains 0. 2 square equals to 4. And 4 square equals to 16. And the next thing we need to do is to add up all the squared deviations. We sum them up. So we have 16 plus 4, 20, 20 plus 0, 20, 20 plus 4, 24, and 24 plus 16, that gives us 40. So that we can apply the formula for variance, which is variance equals to summation x minus x bar into bracket square divided by n. That is summation d square divided by n. You know, this x minus x bar, we have represented it by d. So when we square it, it is still the same thing as d square. So either you write it or you write this, it's still the same thing you are talking about. Since this d stands for deviation, therefore the variance equals to 40 divided by 5. Remember that our n from A is 5. Therefore, the variance equals to 8. And now to the second example. The question says, find the variance and standard deviation of the data below. And here is our data. So let's see the solution to this question. First, we find the mean. And we do that by using the formula summation fx divided by n, or summation f. In this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 values in our data set. Therefore, after adding everything together, we divide it by 10. That is the number of values in our data set. And that gives us 43 divided by 10, and the answer to that is 4.3. That means the mean of these values, the mean to this data set is 4.3. Just like we have done in the first example, the next thing is for us to draw a table. And in this case, we should take notice that in the first example, the values in our data set are not repetitive. That is, we do not have any repetition in our data set. But in this data set, or set of data that we are given in this second question, we have some data that repeats themselves. Therefore, we have to include the frequency column in our table. And we can see clearly that 2 appears 3 times. That is 1, 2, 3. You can see 2 appears 3 times. The frequency of 2 is 3. 3 appears only 1 times. So 3 is our frequency of 1. 4 also appears only 1 times. So we have our 4 to have frequency of 1 also. And you continue like that, you can see that 6 appears 3 times. 1, 2, 3. That's why 3 is having the frequency of 3. That's why 6 is having the frequency of 3. And all other data, they appear 1 times. Therefore, since we have our mean to be 4.3, the next thing is to get the deviation of each value from the mean. Deviation of 2 from the mean, which is 4.3, is minus 2.3. Deviation of 3 from the mean, which is 4.3, is minus 1.1. 4 minus 4.3 is minus 0.3. 5 minus 4.3 is plus 0.7, or we say 0.7. 6 minus 4.3 is 1.7, and 7 minus 4.3 is 2.7. Remember that this 4.3 that we are subtracting from the values is the mean that we have gotten from here. And we denote this x minus x bar by d, which stands for deviation. In this case, the mean deviation. Now, the next thing is to square the result we obtain from here. So minus 2.3 square gives us 5.29. Minus 1.3 square gives us 1.69. Minus 0.3 square gives us 0.09. 0.7 square gives us 0.49. 1.7 square gives us 2.89. And 2.7 square gives us 7.29. Now, the next thing to do is that you multiply the frequency by the square of the deviation, that is their deviation squared. You multiply each frequency to it. Because this data is having a frequency, we have some value that are repetition. Unlike the first example where we do not have to multiply the square deviation by the frequency of each value, because those values only appears once. So what we are going to do now is to multiply 3 to 5.29. 3 times 5.29 gives us 15.87. Here the frequency of this is 1. Therefore, even when you multiply it to a square deviation, you will still have the same answer. Likewise, this we still have the same answer. This 1.1 multiplied by 0.49 still gives us 0.49. But in this case, the frequency here is also 3. So we multiply 3 to 2.89. 3 multiplied by 2.89 gives us 8.67. And 1 multiplied by 7.29, the answer remains 7.29. So the next thing we do is to sum up all the frequency multiplied by square deviation. We sum everything under this column, we sum it up, and after we added everything, we arrive at 34.1, which we call summation FD squared. Now remember that our frequency, when we add them together, the summation of all the frequencies is also called summation F, and we can also call this N, meaning number of values. So in this case, the total number of values we have is 10. Therefore, applying the formula for variance, which is summation FD squared divided by N. You know, we have seen this formula before when we are talking about the formula used in calculating the variance. And this D is still the same thing as into bracket x minus x bar close bracket squared. So in this case, our summation FD squared is 34.1, and we have it here. Our N is 10, so we put the 10 down here, and the answer to this is 3.41. Therefore, the variance for this set of data is 3.41. Next is to calculate the standard deviation. And we said to calculate the standard deviation, what you need to do is square the variance. Take the square root of the variance, That is, to calculate the standard deviation, what you need to do is take the square root of the variance. So we take the square root of the variance, and the answer to that is 1.8466. In summary, in this video, you have learned that layer of dispersion measures how the values of a set of data spread away from the center of the data. The range, variance, standard deviation, interquartile and semi-interquartile range, mean deviation, percentiles are all measures of dispersion. The range of its data is obtained by subtracting the lowest value from the highest value in the set of data. To calculate the variance, you need to calculate the mean first, then get the deviation of each value from it, Square the deviation, take its summation and divide the result by the total number of observations. And also, you have learned that the standard deviation of a set of data is the square root of the variance of the set of data.